In this video, we're going to talk about solving rational equations. Now we have our fractions, but now they're involved in an equation. All right, so the main strategy we have is that when there's a rational fraction as part of an equation, our first major goal is to make sure there's no fractions anymore. We can't solve for the x when it's in the bottom of a fraction, because it doesn't make sense for our final answer to look something like this. Right? X isn't by itself because it's still part of this fraction, so I really need to get the x's out of the bottom of the fractions first. All right, so that's really our only major goal to start, and then once the fractions are gone, then we just consider it to be a different type of equation. All right, so here's a case. We have this x we're trying to solve for, but it's in the bottom of the fraction. So how do we get things out of the bottom of the fraction? I just have to multiply by x. I multiply by the denominator because that's going to end up canceling out. One thing I have to remember is I have to multiply the entire side and the other side. So I'm multiplying the whole left-hand side by x and the whole right-hand side by x. And on this right-hand side, it has to distribute in. So I'm going to get x times 2 over x. The whole reason I'm multiplying by x is that x and that x cancel out, and I get 2. This x is also going to distribute in. I'm going to get plus 3x. Right-hand side, 5 times x is just 5x. And this is one of the difficult things with rational expressions. I don't know if it's necessarily difficult, but like you start with a rational expression, your first goal is to get rid of the fractions, and then you get some new type of equation you have to remember how to solve. In this case, it's just x's, so this is a linear equation, which means we want to get all the x's to one side, so I'm going to subtract 3x from both sides. And then now that I have the x over here, I want to get rid of that too, and x equals 1. And we've kind of seen this with log equations before. When you're solving a log equation, you have to make sure your final answer makes sense in the original problem. I have to make sure I can actually plug 1 in. And I can plug 1 on the bottom here because I can divide by 1. So this actually is the answer, x equals 1. 2 over 1 is 2, plus 3 is 5. By multiplying an equation by the denominator of a fraction, we can get that fraction to cancel out. So we just saw that. Just be careful with distribution and FOIL. Remember, you're multiplying everything on one side by that term. If your term ends up being more than one term, you're going to have to do more distribution. So let's see some more examples so we can be careful with these types of things. All right, right here, I have a fraction. I need to get this x out of the bottom of the fraction. The only way I can do that is multiplying by the whole bottom of the fraction because all of this is grouped together. So I'm going to multiply both sides by x minus 5. The left-hand side, there's no thing to distribute to. It's just x minus 5 times this, and the x minus 5 cancel. I just get 9. On the right-hand side, I have these two things times these two things. Whenever you have 2 times 2, you get to FOIL. That's x squared minus 5x plus 3x minus 15. And this is the thing with rational equations, is you start with a rational equation, but after getting rid of the rationals, now you have a new type of equation you have to stop and think about. Okay, now how do I solve this new one? This new equation has that squared, so I know this is a quadratic. Generally, when we're working with a quadratic, we're going to get 0 on one side, so I'm going to subtract 9 from both sides. So I get 0 on one side, x squared. Combining these two like terms gives me plus 2x. Combining these two like terms gives me minus 24. And now quadratics, again, we have two main ways to solve them, the quadratic formula and factoring. I can factor this one quickly because it's the shortcut one, where I can just do x plus 6 times x minus 4. I can set each of these pieces equal to 0. I get x equals negative 6 and x equals positive 4. I have to do one final check to make sure these make sense in the original problem, because not everything makes sense for rationals. And as long as x isn't 5, I'm good. So these are both my final answer. Negative 6 and 4 both solve this problem. All right, here's another one. In this case, we have multiple fractions. So we could take everything and multiply by x minus 1, everything and multiply by x plus 1, everything and multiply by x squared minus 1. That's going to make it pretty complicated. So we always want to find the smallest thing we can multiply by to get everything to cancel. And if you know about your factoring shortcuts, you can quickly see that x squared minus 1 can actually be factored into x minus 1 times x plus 1 using the difference of squares technique. So actually, I only need to multiply both sides by x minus 1 and x plus 1. Because now on the right-hand side, both of those cancel out, so that's gone, and I just have 4. Here, there's this plus sign in the middle, so I have to remember this whole thing is going to distribute into both. So when it distributes into the first one, the x minus 1s cancel, and I'm left with the x plus 1 part. When it distributes into the second one, the x plus 1 parts cancel, and I'm left with the x minus 1 part. And if you have a middle step where you need to write it all out, that's fine. But I'm just knowing the parts that cancel and what's left behind. Combining like terms. Dividing by 2. All right, so this problem looks really complicated at the beginning, but the actual equation you end up at the end is pretty simple. The only real trick is knowing if you can factor something, break it down into its pieces first, so you can see the smallest thing you need to multiply by. So I didn't have to multiply by 3 separate things. This one thing actually took care of all the fractions. All right, here's one for you to try on your own. Go ahead and solve this rational expression. I'll show you the answer in 3, 2, 1. And this is the answer you end up getting. So let's just quickly walk through it. First of all, we need to get this x plus 2 out of the denominator, so multiplying everything by x plus 2. I remember it distributes in, so when it multiplies by the first thing, the x plus 2's cancel, and I just get that 2. And then this negative 3 is also going to multiply by x plus 2. I have to remember to distribute negative 3. And make sure you get that negative sign in. So negative 3x and minus 6. And then this is a linear equation. So I got the x's on the right by adding 3x. Got the numbers on the left by subtracting 2. And then just dividing by 4. And that gives me my final answer down there. All right, so when working with rational equations, just remember pretty much the first thing you want to do, get rid of the fraction by multiplying by its denominator. And that idea is pretty simple. You have to be really careful with things like distribution, things canceling out, how to solve the resulting equation, that type of thing. But the basic idea of what you're doing should be pretty straightforward. Just get rid of the fraction by multiplying by its denominator.